So looking at the hazards caused by radiation, the, the ways it causes hazards, the differences between the three types of radiation, the effects, and how we protect and measure that radiation and protect ourselves from it and measure it. There are two key terms that you need to be familiar with. One is contamination, where the source of the ionizing radiation is on or in something. So contaminated water would contain a source of ionizing radiation, whereas irradiation is simply being subject to that radiation. So strawberries, for example, are irradiated in order to kill the bacteria in them and on them so they last longer. But those strawberries do not contain any radiation. They do not contain any source of radiation. Whereas if you dipped your strawberry in uranium, then it would have uranium on the outside and it would be contaminated. So there is a difference between contamination, where the source of the radiation is in or on something, and irradiation, where something is simply being subject to the radiation coming from the source. So, having cleared that up, hopefully, we have three types of radiation that concern us: alpha, beta, and gamma. Alpha outside the body isn't terribly dangerous because it's absorbed by air, by sheets of paper, by clothes, and by the layer of dead skin outside the body. Being dead, it can't be damaged, and so alpha is not particularly dangerous outside the body, whereas inside the body it is tremendously dangerous. It's very ionizing, so it will do a lot of damage over a short range to the living tissue that is exposed to it. Beta is dangerous outside the body because it can penetrate that layer of dead skin on the surface and ionize cells beneath. Gamma likewise can penetrate, does penetrate the skin, but isn't very ionizing and so is less dangerous than the other two inside the body. Alpha being not very dangerous outside the body at all because the radiation can't get in. So inside the body, alpha is tremendously dangerous, beta less so, gamma less so than beta. So we have to remember we are comparing sources of equal activity here in order to say these things. Clearly a more active gamma source is more dangerous than a less active beta source because of the level of activity, the radiation it is producing. So the effects of these then, well, alpha is a large, massive, that is to say, has a large mass particle, and it has double positive charge, all of which means that it is more likely to have collisions, and the collisions it has will result in more damage. Beta, much smaller, much less massive, 8,000 times less massive approximately, and so it doesn't do so much damage, but it will do damage over a longer range, so less damage with each collision, but more collisions. So, more collisions over a longer range. Gamma, not very ionizing at all. So, the sorts of things that radiation exposure causes: radiation sickness, which would be nausea and vomiting, skin inflammation, and radiation burns. And I'd always say radiation burns rather than simply burns. Death, of course, but that's not generally an accepted answer in exams. And because of the cell damage, cell mutations, and cancer then. So radiation sickness, radiation burns, cancer are the three principal causes or results, sorry, of radiation exposure. So to protect ourselves, we keep our sources in lead boxes when we're not using them. We take them out only as much as we need to and put them back when we're finished. We use tongs to handle them, never directly. We point the source away from ourselves and others, and we put it back when we're finished. Now, you'll have noticed hopefully that you had photographic film with nothing in front of it, between it and the source. Then you had a piece of card, and then you had a coin. So here, a lot of exposure to the photographic film, and it's gone black. Here, some of the radiation has been absorbed by the cardboard. That would be the alpha, of course. So the beta and gamma have come through here, and so we have less radiation than here, less exposure than here because the alpha has been absorbed here. And then here, both the alpha and the beta have been absorbed by the coin, and so only the gamma is getting through, so less exposure, but still some exposure. In industry, well, the sources they use there can be tremendously active, and so we have a lead-lined room, we have lead glass to protect the operator, and we also have photographic badges on everyone who works in this sort of environment, so that these badges are taken away and developed regularly and frequently to tell the dose that this person has had, their dose meters. And if their dose is near or over the safe level, then they'll be sent home and told not to come back until enough time has elapsed that their average dose will fall below the safe level.